Perfect. Okay. Hi, everyone. Thank you so much for being here. I'm very excited. So we had over 500 people register today. So I'm really excited for this event. I'm Naomi, and I am the chair-elect for the Student and Postdoc Special Interest Group at OHBM. Today, Dr. Bradley Wojtek will lead this workshop on best practices in scientific writing. He is a professor at the Department of Cognitive Science and the Collegio Data Science Institute and the Neuroscience Graduate Program at UC San Diego. He is both an Alfred P. Sloan Neuroscience Research Fellow and a Kavli Fellow of the National Academies of Sciences. After his PhD at UC Berkeley, he joined as their first data scientist, where he helped build their data science team. His research focuses on both neuroscience and data science. Wow, the numbers are going up quickly. Okay. He combines large-scale data science and machine learning to study how brain regions communicate with one another and how that communication changes with aging and disease. He is an advocate for science communication and outreach. His outreach work has ranged from Scientific American and NPR to the San Diego Comic-Con. He is currently writing a textbook regarding data science and approaches to neuroscience. And as many of you already know, he authored the book, Do Zombies Dream of Undead Sheep? And with that, I'm going to let Dr. Wojtek take it from here. Just as a reminder, we are recording this workshop. It will be posted online. And the last thing, if there are any technical issues at all, please message me privately or you can email me and I'll try my best to sort them out. Thank you so much for being here.
Thank you, Naomi, for having me. Thank you, everybody, for showing up on this virtual meeting. I have not been to OHBM in, I think, a decade. The HBM meeting, it's not exactly my field of work, but I was just thinking about going, not this year, but hopefully again next year. So as Naomi said, I'm a faculty member at UC San Diego, and my research spans a lot of different domains. We actually just got a new lab photo yesterday, so I've got to show off the new lab photo. So this is my research group. We are a mix of PhD students, postdocs in cognitive science, data science, and neuroscience. And so our work sort of sits at the interface of these different areas. And here today, I'm to talk about this idea of how do we communicate the science that we do to our public, right? To the public. And I taught a course on this for graduate students here at UC San Diego. I don't know, I want to say like 2015. And I was going over my old course materials and slides in preparation for this, and it's amazing how much has changed even in the last 8 years. But a couple of the fundamentals are still the same. Now, first of all, I am by no means an expert in this in terms of the pedagogy or science communication. I mean, there is a whole academic domain that is focused on the most effective communication practices. And I am a recipient of some of those pieces of knowledge. I've done a little bit of speaking and training on these things, but I'm not I'm not creating new knowledge in this area. But I have hoped here in the 45 minutes to distill out some of the pieces of information that I've learned over the years. And the primary one is that your audience matters. So when I taught this when I taught this communicating science to the public class to graduate students, we began with this idea of how do you tailor your message, both the values of the listener, the background, and so on, right? How you communicate your science is a function of the group to whom you're communicating it. So if I am giving a presentation at a scientific research conference, that is a very different kind of lecture than if I am giving a presentation at my daughter's elementary school. That is perhaps unsurprising, but thinking about all of the very nuanced differences in between those two extremes of elementary school versus giving a talk at HBM, there's a lot of nuance in there. And so understanding that nuance can be very important. When I taught this class, and one take-home message that I want to give away to you also is trying to understand how best to communicate your science under different scenarios in terms of like your, there's like the elevator pitch version of how you talk about your science, right? That is the idea that you're in an elevator with somebody for about 10 seconds and you have that amount of time to explain to them what it is that you do. So there's the 10-second version. So going back to the introduction that Naomi gave for me, I am a neuroscientist who uses a large amount of data and some machine learning methods and techniques to understand how 86 billion neurons in the brain communicate with one another. That's the very rapid, quick 10-second pitch. A different variant of that is we care very much about how we measure data about the body and what that can inform us. Not as good. That's what I'm sort of working on, but that's a little bit of a newer direction that the lab is going. So I need to nail that kind of pitch because it doesn't feel quite as interesting. It doesn't feel quite as impactful. Then there is the cocktail party pitch, right? You're at a party with somebody that you haven't really met, and somebody introduces you, and they said, "Oh yeah, and they're a neuroscientist or whatever." And then the person that they're with says, "Oh, that's fascinating. What kind of work do you do?" You have more than 10 seconds, but you don't have more than 5 minutes. So you've got maybe 2 to 3 minutes to explain the kind of work that you do to somebody who may have very little scientific training in a situation where they maybe are easily distractible and can very quickly get bored. And then there is the much longer version. If I would give an hour-long presentation of my scientific research. And sort of the goal, I think, for everybody here should be to be able to do these sort of different versions just at the drop of a hat. If I ask you right now to give the 5-second, 10-second elevator pitch, you should be able to do that. If I ask you to give a 3-minute conversational pitch, you should be able to do that. If I ask you to give a 45 to 60-minute chalk talk about your research, you should hopefully be able to do that eventually too. And so thinking about how you tailor your message, though, is important because of the different audiences that you may be interacting with. So why is it all important? What does this matter? So in particular, when we talk about neuroscience, for good or for ill, still holds a particular public power. And by that, I mean, there's been research that has shown that people admire neuroscience as a field very highly, more so than maybe even other scientific fields. A consequence of that is this very fun, I want to say even surprising, but to me, exciting paper that was published in 2015. This is a news article about it where they talk about neurobabble makes nonsense brain science more believable. And so in this paper, they actually did some questionnaires to talk a little bit about people's perspectives on neuroscience. So this is a paper from Fernandez-Duque in Journal of Cognitive Neuroscience in 2015. And here you can see that one of the things that they'd asked was the level of admiration that people hold for different levels of sciences. And so in neuroscience, highest level of admiration on this 10-point scale, people really admire neuroscientists and the work that we do. The consequence of this that they showed in this paper, however, was that if you just add nonsense brain terms to standard psychological findings, people will tend to believe it more, even if you just add a bunch of nonsense stuff that has actually nothing to do with real research. So if you run a study showing that, and I'm making this up, so bear with me here, forgive me, for an experiment showing that, I don't know, people who have long COVID suffer, more negative mental health effects for the first 6 months after their COVID diagnosis. It's a very real kind of finding. I'm sure it's been replicated, those kinds of things over and over again. If you say that exact same thing to somebody, but you add in and brain imaging scans show that there are neural differences between people who have these negative long-term consequences of long COVID and people who don't. You don't say anything else. You just say there's a brain thing about it. People are more likely to believe the results, even if you give no information whatsoever. And in fact, you just make it up. And so we have to be very careful about how we communicate neuroscience to the public because of this sort of privileged status that we as a field hold. And my concern and worry often is when this privileged status is potentially being abused by just sort of adding brain-related terms and phrases to things where potentially they don't belong or there's no evidence for them, right? So like social media is addicting because we get a dopamine hit. Okay, what is that told us? That doesn't add any information beyond social media is addicting. Adding that because it gives you a dopamine hit, doesn't really, it's very non-specific, very possibly not true, but people will tend to believe it more. But that extra belief comes potentially at a cost of wearing down that trust over time. Okay, so anyway, let's talk a little bit more then specifically about how do we communicate with these different audiences. And so one audience with whom we'll often communicate is the educated scientists, our colleagues and friends through the peer review process, through grant writing and so on, through conferences like HVM. But we can also end up communicating with the educated public. So these are people who have some science training or background potentially. And so, for example, years ago, I had done a research project looking at patients who had undergone a surgery called a decompressive hemicraniectomy. And this is a surgery where a piece of the skull is removed temporarily from patients who have suffered traumatic head injury that has caused cerebral swelling. And normally the brain, when it swells, and due to traumatic brain injury, doesn't really have any place to swell to. And so it swells into the inside of the skull, and that shuts off the blood supply to the brain, and people can quickly have a stroke and die under that scenario. We'd worked at UC San Francisco with Dr. Jeff Manley, who had done these surgeries on decompressive hemicraniectomy, to show that during the several months when the piece of skull is off, to just compare the kinds of signal we can collect using EEG from the side of the head with the skull and the side of the head without the skull. And this was sort of a technical paper that I'd done because one of the things that I do in my research lab is we work with patients who have intracranial EEG recordings, and we just were trying to look at the different signal qualities between intracranial and extracranial recordings. And these decompressive hemicraniectomy patients sort of served an interesting control case where you have side of the skull and side of no skull. So we'd written this paper, and shortly thereafter, I don't know if people remember this, but Representative Gabby Giffords from Arizona had actually been shot back in 2010, shortly after this paper had come out, and had actually undergone this surgery of a decompressive hemicraniectomy. And so this sort of public event that was related to this niche scientific thing that I had been doing had happened that was kind of relevant to some of the things that people were very interested in. And my PhD advisor, Robert Knight at UC Berkeley, is a neurologist. And so he is a medical doctor that's able to talk about this kind of stuff. But we were getting a couple of phone calls from news outlets, asking about what this procedure is. And the surgeon, Jeff Manley, Bob Knight, they actually let me talk a little bit about the kind of research that we were doing and how it relates to sort of this sort of public phenomenon or this public news interest story that had just happened. Because Representative Gabby Giffords happened to have the same kind of surgery, and she survived and recovered pretty well. And this sort of interaction with the news media then led to a couple months later, another series of studies that I had done had been published, where I was working with people who had unilateral strokes to the prefrontal cortex or basal ganglia, and looking at how that impacted working memory and sort of information transfer between the two hemispheres in the intact, non-damaged half of the brain versus the half of the brain that had stroke damage. And so shortly after this sort of media event had happened, and it wasn't a huge thing. I wasn't like on morning news shows, national news or anything like that, but I had just given a couple of quotes here and there to a couple of news outlets. I was then asked to talk about my research for a couple of other organizations, sort of subsequent papers here on stroke and stroke recovery. And so the Washington Post reached out to me and a couple of other news outlets, and actually was asked by the Washington Post to do a live Q&A. And so this is early in 2011. I had just finished my PhD, and I was asked to do this live Q&A about Representative Gabby Giffords, and I was trying to feel super nervous in this, I have to say, because I'm not a medical doctor, but I was trying to talk about what I knew about her procedure that had been done. And subsequently in another sort of live Q&A that I'd done about the stroke recovery stuff from the other papers, So I was very nervous to do this. I was trying to be very, very careful and precise in the language, right? And you can see these maybe are in looking back, 12 years later. One of the questions was, when will we know if Representative Gabby Giffords will be able to talk? If she can speak, how long until she reaches her full potential? And I said, there's no way really to be certain. It's like an unsatisfying answer, right? But scientifically, that's the only answer that I felt like at the time, especially, under the time pressure, that was the only honest one. So there's a lot of variability between subjects in terms of their recovery. As Dr. Brown said in his article, Representative Giffords' youth and intelligence will work in her favor. Recovery from brain damage is a long process that will require a lot of work and rehabilitation. That said, if recovery does happen, speech generally improves over time, albeit somewhat very slowly. And so trying my best, I'm not giving flashy answers here. I'm just trying to be as honest with, this sort of interested public as possible. And so when you're doing this kind of work, that's my recommendation is be honest. And if you don't know, say, I don't know. I actually just came out of a meeting this morning with a group of physicians who are trying to work at this sort of interface of using ChatGPT and other generative AI large language models to aid them in some of their clinical work. And it turns out that one of the most important modifications that they made in terms of the public trust of AI assisted conversations clinicians have with their patients is if they have the AI models, the large language models, also be able to spit out, I don't know, or I am uncertain about an answer. So rather than having these sort of binary outcomes of, there is this thing or is there not this thing, they modified some of these large language models in order to have them just be able to say, I don't know. And the power of I don't know is incredibly strong. To be able to say, I don't know, but I know how to find out, and I know an expert to whom I can turn that will be better suited to have this conversation with you, is incredibly important. So in terms of 12 years ago, this kind of conversation that I was having, during this live Q&A event through CBS and Washington Post, to even now trying to actually develop large language models that will also say, I don't know, when there is a high level of uncertainty. And so this little experience that I'd had with some of these outlets at this time had paralleled some of the sort of public science writing I'd been doing on a neuroscience blog that I was writing at the time. I enjoy writing. I find it very satisfying. Some people play music, some people do art. For me, writing is just one of those sort of hobbies of mine. I don't get to do it as much anymore now that I'm running a lab, but I still do a little bit of writing for fun here and there. And I used to do a lot more. And one of the things that I was very fascinated about was, where does the history of our ideas come from in neuroscience? Like, where do ideas come from? How do they start? I'd written a thing on the history of invasive brain surgery and stuff like that. And during my PhD, I had met a person, Robert Galambos, who was a neuroscientist, who passed away a number of years ago now. Galambos had been the person who discovered that bats use echolocation in order to navigate. He discovered this back in Harvard in the 1930s using pretty clever experiments. And then he went on to become a neuroscientist, and he invented the device called a brainstem auditory evoked potential system, which will just by chance of the folding of the cortex, the sort of superior temporal plane of the auditory cortex is such that if you present an auditory sound to somebody, a tone or something like that, the scalp EEG signal actually gets picked up sort of at the vertex of the skull here pretty weakly. But Robert Galambos had shown that if you present a series of clicks to somebody, you could pick up sort of the 7 or so different relays of the auditory nuclei system from the scalp EEG non-invasively. And this was a project that he had done for the US Navy back in the 1940s, because the Navy was concerned that when they were drafting people into World War II, that people were faking certain disabilities like hearing loss so they could avoid the draft. And so the Navy had actually asked him if he could come up with a method for a foolproof method for seeing if somebody's hearing system is intact. And so he came up with this thing using EEG, and now this is this BAEP, brainstem auditory evoked potential system, is done on pretty much every single baby born in a hospital in in most of the developed world. So a day or two after birth, a nurse comes in with a little microphone, headphone set that has a single EEG electrode, and they play a series of like 1,000 clicks, just very rapid. It's like 10 or 11 times clicks per second. And that is able to test the fidelity of the baby's auditory system. And so I found this really fascinating, this history of this person. And so I ended up writing a guest blog years ago for Scientific American on the sort of history of echolocation and bombs and sharks, which are other sort of interesting side stories, right? This is like clickbaity headline, but other interesting sort of side tales of Robert Glambos's history. And I find this stuff to be very fun, right? And it helped me exercise my muscle of how to tell a story that is factually correct, historically accurate, but sort of uncovering these interesting histories. Now that process can be very different than, say, communicating with other groups. Like I do a lot of talks at local schools here in San Diego, and used to up in the Bay Area when I lived up there. So communicating with teens and young adults is a little bit different. And so one of the things that I often do when I'm presenting and talking to kids at schools, especially high schools, I usually don't start this with my daughter in elementary school, but like at high school, for example, I might show something like this, which is my fall semester, my first year of my undergraduate University of Southern California, showing them my undergraduate GPA report card for that first year, fall and spring semester. And so you can see that my undergraduate GPA for my first year was 1.66. I failed a class called Quality of Life, which often kind of gets a chuckle out of the high school students. And this is to kind of set the stage and put everybody a little bit at ease and say, I am a professor here at UC San Diego. And like Naomi did, you sort of read off this list of credentials that can sound very intimidating. I remember as a first year PhD student, watching job talks and things like this, and just seeing these postdocs who are on the job market give these incredible talks with just this huge amount of research and all of these papers done. And here I am as a first year PhD student who barely scraped, lucked his way into a PhD program, given my undergraduate, record here, not knowing how to write even run a research project or, do anything close to like writing a research paper, and seeing these people who are just a couple of years, maybe 5 or 6 years ahead of me, these postdocs giving job talks at, these universities, and just going like, I am not cut out for this. I cannot do this. I am so much less intelligent and accomplished than these people. I do not see an option or an opportunity for me to get a job in academia or anywhere else. I don't know why I'm in a PhD program. And so the farther along I got, the more I realized that you just kind of gain experience over time. It's a very slow, long process, but just because you hit a roadblock doesn't mean you should give up. And so when I'm talking to these high school students, I present this and say, this is where I started from. And I wanted to quit. I was a physics major. I was obviously very bad at it. I withdrew from my first physics class. I got a D in my chemistry class. I got a C- in my calculus class. I obviously am not cut out for this kind of work. I then go on to say, but I didn't quit. I tried to figure out how to get my act together. There's a lot of just stuff happening in life. And so I sort of begged and pleaded my way back into the university because I had been on academic probation for so long that I'd been kicked out of my undergraduate program. And so I went and spoke with my academic advisor, and as part of getting back in, I spoke with the, university counselor, and everybody agreed that I should have one more semester to try and get my grades back up. And this is the letter that I saved from 23 years ago now, from the vice provost of University of Southern California, where I did my undergrad, saying that they had authorized me to reinstate me for one more semester of probation. And I had to sort of meet all of these sort of minimums and so on. And to really emphasize that, yeah, there can be times that feel very overwhelming, but, if you reach out and ask for help, you can, try and find people that are, willing to go to bat for you, that are willing to listen to your story, and who are willing to then give you, the opportunity to succeed. And I've been very vocal about this pathway that I had of failing out through my undergraduate, getting reinstated, and being very vocal about all of my various academic rejections and failures. So years ago, when I was a PhD student, I started actually tracking everything, every grant that I applied for, fellowship that got rejected, every paper that got rejected that I submitted, and keeping that in my CV. And this is one example, but this is one of those things that like goes semi-viral every now and then, this sort of CV of failures. And this is a message from a colleague that I received a couple years back, saying that they had an undergrad in their lab who was volunteering and was feeling very discouraged about her GPA and what it might mean for her aspirations in science. And then she read something on my website that gave her some renewed hope. And it's such an amazing privilege to be able to communicate the honest trials and tribulations of the work that you do, and things that felt like such failures at the time, but to then be open and communicative about those kinds of like real frustrating struggles, some of them self-inflicted, some of them not. But the process then of how do you work through them? And years later, still getting messages like this saying, hey, thanks, for talking about this kind of stuff. And like I said, I go out and I give talks at high schools and things like this, to talk with students about these various career paths, and how you go from those moments of failure, reflection, and then moving past them, right? And so this is a very different kind of communication about the scientific process than you would give at most lectures at, say, HPM, right? It's talking about the things that went on, and that are sort of like the truly behind the scenes stuff, behind the scientific papers and results that you're presenting, right? And this to me is one of the most rewarding aspects of this kind of work. So this is an email I got after I had spoken at this one particular high school. I plan on going to college as undeclared, but your presentations really opened up to me the world of neuroscience. Although I can't say with 100% certainty that I'll stick with neuroscience, I wanted to thank you for shedding a little light onto what I wanted to do with my life. Talking about to these audiences about these things has all of these interesting kind of downstream effects that I wasn't ever anticipating, right? I liked going out and I like hearing other people's stories about how they got to where they are. And I like to talk about how those stories are different or maybe similar, how they intersect with my own experiences, and what can we learn from that? And I get joy out of that kind of conversation with people. And so I do it just because I enjoy those kinds of talks and conversations. But then to get this kind of feedback, it's going through, I have a whole directory on my computer that's just called Happy, where I save little snippets like this. When I'm very frustrated or angry if a grant gets rejected, I go back and say, okay, this is why I do this job, right? These are the nice little comments that I've gotten. It's, I don't know, I don't know how to describe it, right? It is just a wonderful side effect that I was never anticipating. And so there's that kind of conversation where you're like very open and honest about any kind of like struggles that you've had. But then you can go a little bit differently and say, well, there's also knowing the audience, which could be a very broad audience, maybe non-scientists, not people at high schools, in this sort of captive environment. And that's a very different kind of conversation too. And so for me, this whole side career that I had very briefly for a couple of years as like a world zombie brain expert grew out of this sort of blogging that I was doing, just thinking about like history of where ideas come from and stuff. And I, in particular, was studying a lot about functional localization. So the history of functional localization largely comes from working with people who have very specific kind of brain damage. And, I was trying to trace back these histories of functional localization through studying people who had very specific kinds of brain damage. Excuse me. And so one year around, like I want to say Halloween time, a friend and colleague of mine, Timothy Versteinen, who's a professor at Carnegie Mellon now, He and I, sort of as a joke, published a couple of blog posts about zombie brains. So just sort of taking this, functional localization approach and sort of saying, well, why is it that zombies can't speak and communicate? Why is it that they can't move, quickly, or why is it that some zombies move fast zombies, and some zombies are sort of slow and shuffling and ambling? So we just gave this joke about, what a zombie brain must look like, given some of these behaviors that we observe from zombie movies. And so Tim had actually created this really awesome putative zombie brain. So normal MRI scan here in black and white in the back, and then you could see that there's a lot of tissue degeneration in the zombified state. And so I gave a talk at a bar in San Francisco in like 2010 on this zombie brain thing. And it was at, public event. And it was just a ton of fun, super successful, just a bunch of people drinking in a bar, coming up to me afterward with questions about, various zombie movies and, behaviors from certain zombies in certain scenes in certain movies and why they might do that. And so we then sort of took it a step further, Tim and I, and at the Society for Neuroscience conference one year, we created a poster, fake zombie brain poster, and just hung it up on an empty poster slot at the SFN conference and just kind of let it sit there. And so we did this whole fake, we called it consciousness deficit hypoactivity disorder, case study of CDHD, which is our like overly clinicized version of zombieism. And just kind of stuck this up, and that was super fun to watch people. I have a photo of one of the security guards who was working at the conference, came over to this poster and was reading the poster, and like he called his friends over. So not even neuroscientists at the Society for Neuroscience conference, but just like a guy working there as a guard, and his friends came over and took a look at this. And so this idea of, okay, we can teach neuroscience in this publicly accessible way using something that's, pop culture-y, kind of hot at the time, but still in a way that is honest and truthful about the strange history of neuroscience, as well as about how we know what we know, right? And this led to, like I said, a very strange side career for a while. I got to do things like, I got to go to San Diego Comic-Con and sit on some panels a number of times, which was super fun. Wired magazine created this infographic of the science of surviving the zombie apocalypse using our sort of brain data arguments. And then the fun thing about this is going to a conference like that and getting emails and stuff from people afterwards saying, I'm a grown man with a family and a career, and Brad made me want to become a neuroscientist, or somebody else saying, I accidentally started liking science stuff thanks to you. Right? I really wish I could like follow up with some of these people years later and figure out what happened to them. Right? But these kinds of messages are like, oh, something that we're doing here, even though it's really silly and super kitschy, is resonating with people, because we go to these conferences, we go to these events, we talk about slow versus fast zombies, and that allowed us to talk about the differences in what we know about motor control of functions of, say, the cerebellum versus the basal ganglia. And suddenly you've got like high school kids arguing with each other at this thing about, whether or not fast zombies are likely to have some kind of cerebellar or basal ganglia degeneration, right? These are words that they'd never even heard before. Now they've got very strong and passionate opinions about them. That's super fun, and it is another aspect of this kind of science communication that's really rewarding. Right. And we actually got approached by TED Ed, which is sort of online TED videos, little snippets of stuff to record a video that they animated. And so our little like TED Ed video has been used in classrooms, all over the world to talk a little bit about, what we know about the brain and functional localization. And like last I checked a couple of years ago, it had, collectively these two videos that we had done over 1 million views, which it's very surprising for something so goofy, but definitely not where I thought my career would go. And in fact, Tim and I had a very long conversation in the lead up about this, because we ended up writing a book about the zombie brain for Princeton University Press, or with Princeton University Press. And we were both, he was on the job market at the time. I was a postdoc, and I knew I wanted to go on the job market too. And we're like, this is going to kill our careers, right? Like nobody will ever take us seriously as neuroscientists ever again. At which point we just kind of decided, well, screw it. If that's the case, that's not our problem. We're doing this because we enjoy it, and because it's actually a really fun way of talking about science to people who may not otherwise know anything about the brain. And so we took a big gamble and we did it, and it was a ton of fun. Even to this day, every now and then I get asked to do a zombie brain lecture, and I miss it. I miss doing that kind of stuff. And this then ended up allowing me to even jump fields for a little bit. And so I have a friend and a colleague who's a professor in arts and humanities, specifically English literature and comic books. And he is part of this international conference on the fantastic and the arts, which is a humanities conference on science fiction and fantasy. And I got to give a couple of talks there for a couple of years, where we would talk about neuroscience to humanities scholars. And so, I was like the one scientist at this humanities conference for a couple of years, and it was incredibly fun to be able to sit down with faculty from totally different field and talk about, how science fiction has shaped science. And I don't know about some of you on this call, but one of the things that got me into science was my love of science fiction and comic books as a kid. And that shaped the way that I think about science and what we can do. And then, that sort of vice versa, how then science influences science fiction and the arts, right? And so this is an example of a presentation that I'd given years ago at this conference, talking about the sort of basis of these different kind of hypnagogia, paralysis, hallucinations, and other magical abilities of literary monsters, and talking about, okay, these ideas predate a lot of the neurobiological knowledge, but ideas of people turning to stone or something like that, from the Medusa, are they rooted in paralysis or not? And so this was very fun to be able to have this kind of conversation with a whole different group of scholars than I would normally do. And so, yeah, every now and then for a while there, especially, I get asked to do this kind of public writing about my research or something, and putting it into more sort of lay-friendly context. I don't do this quite as much anymore, although that might be changing here in the near future. I've sort of been missing this and been asked to go back into it, and sort of turned down a lot of offers in the past, but I'm considering writing again for fun, which would be I think a very positive change. Okay, so I'm going to end here in the last couple of minutes talking about social media. And so the social media environment and landscape has changed pretty tremendously. When I used to give this talk years ago, I was very active on Twitter, well, relatively speaking. And I would use it a lot. And, I was using social media in general, Twitter specifically, for communication and outreach, for idea generation, this kind of idea of demystification. So taking really complex ideas in neuroscience, or later on in my career, machine learning and AI, and trying to demystify them, and then sort of you get into the cycle of this communication, outreach, new ideas, demystification, exposure by writing, and then that sort of leads back into this sort of communication and outreach cycle. And so years ago, I used to talk about this in terms of communication outreach on social media. I've quit Twitter back in November. I feel like my life is better for it. But it was kind of a difficult thing and a sad thing to do. I just, I was using it for a long time, the last couple of years, for mostly talking about my own research coming out from the lab, and sort of to highlight the work from the people in my lab and other pieces of cool science that I saw. But then I was mostly just using it for that. And then as people graduated from my lab and new people came in, fewer and fewer people were using Twitter. And so I was like, what am I doing on here anymore? I don't even understand why I'm doing this anymore. And so I ended up quitting. But that doesn't mean that, social media is useless, right? You have these really complex things in the sciences where, these are the kinds of charts that might show up in some scientific papers. Right? This is actually Martin Kaczynski has really beautiful sort of data visualization work that he's done for visualizing biological networks and things like this. And I love these kinds of figures, but if a member of the lay public sees this doesn't really mean anything. I mean, they don't even know where to begin in terms of unpacking this. As a non-biologist, if I didn't already know what this is because I've given this talk before and looked at this graph, I wouldn't even know how to begin to talk about this. And so when you're sort of engaging first in social media, or this really communicating with science public, with these different audiences, you really want to think about, like, how do you start? And so my recommendation is to find your voice, I feel like people sort of adopt a voice. And if they're going to podcasting, that might be adopting a literal voice, where there's like certain styles of speaking. There's like the NPR voice. There's the sort of podcasting voice. There's certain ways. This idea. I first encountered this idea recently, and it's really stuck with me. And I can't get it. There's kind of a way of talking on podcasts, and so I feel like a lot of people try and sort of mimic a kind of style or voice. And I think that does a disservice, right? So my recommendation is to find your own voice. What is it when you're just talking to your friends excitedly about your research? How do you speak? What is it that you get excited about? So going back to this idea of these failures and my CV of failures, right? Talking about all the things that I didn't get, all of the awards and grants and papers and stuff I didn't get. That is very demotivating. And what I found to be motivating was not the scientific papers that I was writing, but the sort of underlying rationale and reasons that I got started in the first place. Why did we care about this paper? We ended with a paper, and the paper is, through the peer review process and, the veneer of impartiality that we have in scientific writing is stripped of a lot of its soul and voice. But we don't get into science to write those kinds of papers. We don't get into science to write a paper, right? Writing a paper is a side effect of communicating that science to your peers. We get into science because, in theory, there's some kind of underlying joy that you get from this process of discovery. And so I encourage everybody in my lab, I still do this when we have some new paper, to just like go back and write a thing, a couple paragraphs even for yourself, if not for the public facing, like a public facing blog or something, about the process that gave rise to the paper. That initial sort of, to use the Marie Kondo spark of joy kind of idea of what got you into this? Why did you do it? And so part of that is finding your voice then, right? Our voices are stripped a little bit dry in that scientific writing part, but we can regain that voice when we're writing for a non-peer reviewed outlet. And another option is when you begin writing, when you begin the scientific communication, find a niche, find something that you enjoy and that you can carve a little, space out for yourself. For me, it was trying to dive into the history of where ideas came from. And then, the last piece here is just kind of dive right in. Begin writing, share it with a couple of friends if you want, post it on social media, do a quick little, video and share it on social media, whatever your sort of format is, but, give yourself a shot and give yourself a chance. The number one barrier is not even trying. Right? And so if you don't start, then you can't share anything with anybody. And so it's better to share something that might be not ideal or not perfect than to never start at all, in my opinion. And there's so many different platforms, right? And the whole thing, the whole market has changed, right? There's blogs and videos and podcasts, but those are pretty saturated and it's very slow to start. LinkedIn you can use, but that's very professional. Instagram, TikTok, Twitter. I mean, there's so many different ways of communicating your scientific ideas out there. Right? Maybe you're more visual. Natalie Shwarnikov, who's a former postdoc in my group, is very good at creating animated GIFs of the sort of scientific questions that the lab was pushing on. And she was fantastic at creating these little educational GIFs that she would share. And that's like a very specific niche thing, but it was wonderful. I love that. And, so it's find those little things that you're pretty good at, that take advantage of your skills, and just, go ahead and share them. And so here in the last 2 minutes, talk about this idea of, for me, I would also use this stuff to generate new ideas. So at, early days of my Twitter usage, I would ask people basic questions of like, what is one core idea that you need to comprehend and understand the brain? Is it basic cell biology, organic chemistry, information theory? I don't remember doing this. Like this is a slide where you could look at like the impressions and stuff like that. What I found was that these kinds of questions like really got people engaged on them. But it felt disingenuous to me because I'd ask these questions and then people leave a bunch of ideas, but like I didn't know what to do with it. Right. And I don't know if people are still on Twitter or use it, but like you'd have these, people that would come on and they'd say something kind of contentious, or they make a statement, and then everybody just kind of argues back and forth. And then 1 year later, that same argument happens again, or 6 months later. And I wasn't really getting any joy out of that. I was like, oh, this kind of drives engagement. Like people click on this kind of stuff, but like, why am I doing it? Like, okay, let's say, somebody has the answer to this is OCHEM, and somebody else has information theory. You're like, okay, what do I do with this knowledge now? I don't know what to do with this. And so for me, the more fun part came from this, like talking, leaving questions on Twitter or other social media platforms, and then having people leave questions to me that then made me realize that there's like a point where maybe I know something about neuroscience that it seems like there's a very strong point of confusion. I just yesterday had a conversation with somebody where once again, the idea of we only use 10% of our brains came up. And that's like one of those brain myths that never seems to die. It's the zombie of brain myths, I guess. All right. And so that demystification process is what led us to end up, writing this book on the zombie brain stuff, because we're like, okay, there's these various myths that people have about how the brain works. Let's write this book about zombie brains in a way that uses like real neuroscience knowledge, takes advantage of the neurobabble thing that I spoke about at the very beginning, to give it this veneer of credibility, to sort of make fun of how easy it is to make real sounding neuroscience out of completely nonsense things like zombies, right? So all of the facts that we talk about in the book are actual real historical facts about how we learn something about the brain. But then it's like all the sort of tongue-in-cheek making fun of, how easy it is to make something sound plausible if you add this veneer of neuroscience to it. And, much to our surprise, this book actually got reviewed in like Science and the Lancet and Neurology Today and all these places. We did not think that people would enjoy this. Like I said, we're very worried about it, but people got a kick out of it. And so that silly stuff also led then to like not so silly stuff. So every now and then, because of that social media presence and sort of this writing and public facing work that I'd done, if people needed comments on news articles about neuroscience topics, they would turn to me and ask me some questions, which is always very fun. I find that very enjoyable. But then I get every now and then asked to like write something, for the field. Right? And so a couple of years ago, when Oliver Sacks had passed away, neurologist who got me into the field in many ways, his writing did anyway. When he passed away, Wired Magazine had reached out to a couple of neuroscientists, neurologists, to ask them, for any comments and thoughts, how he might have shaped the kinds of work that we do. And so last little piece here is this idea of exposure. So I got, funny kinds of stuff over the years, comments, private messages. So for an award I won a year back, somebody jokingly said, confidentially, the whole board was unanimously behind you, not just because we wanted to avoid a mention on the CVs under your failures and rejection section. And then an editor had messaged me years ago for a comment that I had left on Twitter arguing with somebody, and they said, congrats, you get one overrule reviewer number 3 for free card. So it's like, kind of funny to use these social platforms as like a virtual conference where you get to meet people, right? And it's weird to me how much this virtual conferencing idea now has just become pervasive in everyday life, right? When I first taught this class, pre-pandemic, never happened, Zoom didn't exist. And so social media was the only way to do this kind of virtual conferencing, right? And now we are currently very meta doing a virtual conference, talking about with each other, and hopefully, in the Q&A session here, getting to know each other here in the next couple of minutes. And so I'm going to end here on this idea that the good parts, the goods can far outweigh the bad parts of this kind of social public engagement. There are bad parts. We can talk about that a little bit in the Q&A, but I'm going to leave it here on sort of the good parts shared with permission, but I've stripped out names for the sake of, privacy. An assistant professor emailed me a couple of years ago saying that they appreciated the honesty and the sort of stuff I'd written on my lab philosophy page on my website, and how that shaped their own website. And like they're thinking about running their own lab. Or this other comment from a student who had emailed me saying that I don't know them, but they wanted to express their appreciation and gratitude for this lab philosophy page on my website. Their undergrad was very turbulent. They had a poor GPA. And after Googling something like how to get into graduate school with bad grades, my lab's website came up, and they were inspired after reading my academic path. There's a dearth of advice for role models for people in those types of situations. Anyway, they followed the advice on the webpage, and after 2 years of working as a tech in a lab, and getting a master's degree, they managed to get into a PhD program. And so, these are the good parts of the job, right? Like I said, there are some bad parts. Every now and then you get like a weird email, troubling email, even sometimes from random strangers, especially when you write about something like zombies that has certain cultural intersections. But these good parts are, I mean, like I was referring to earlier, I have that folder of sort of happy memories that I keep. And just going through some of these, it almost got me teared up, right? It was just very strong, positive reminder about why we do this kinds of communicating. So anyway, leaving it on, why not social media for academics? And this is a famous letter that went around years ago from an advisor to their lab, where they told everybody that everybody in the lab, everyone works at least 50 hours a week in the lab. You may not want to be as successful, but I'm not asking you to match my time in the lab. By working, I mean you must be doing real bench work. This does not include surfing on the computer and sending and receiving emails for non-scientific matters unrelated to your work. They mentioned that about 60 hours of working time per week is what they consider the minimum time on average to be successful young scientists these days, and they have to put into their lab work. There may be a few lucky rare fellows like so-and-so who had 2 Nature papers already, and they can enjoy life for a little while and still get a job offer from Harvard, but nobody else in the lab has that luxury to play around. So this is why, right? There's sort of still this old school notion that communicating with the science, communicating with the public about your research, social media related to scientific topics or not, is just a waste of time. And I find that to be so counterproductive. And in my particular case, anecdote is not data, but exactly incorrect. My experience with this kind of public communication, writing a zombie brain book, all this kind of stuff didn't lead to any of these long-term negative consequences, of not getting enough bench time in and not getting real research done. I like to think that our lab is a thriving neuroscience and data science research lab, while simultaneously also being a place that places value on public communication, education, and outreach. So I'm sorry for going a little over time here, but I will stop now and stop sharing and go to the Q&A. Thank you, everybody, for your time.
Thank you so much for that talk. It was great. So I just put in the chat box for anyone who has any questions. We have a few minutes for your Q&A.
The bear's name is Asparagus. He was my buddy during the pandemic. Humor is sorely missing in the academic community. Oh, I think a lot of people are humorous. They just are afraid to exercise that in academic settings.
I have a
Gets me
question.
through committee meetings. Yeah. Anyway, sorry. What's your question?
So do you have any good resources or tips for students who want to, start writing some kind of scientific communication or want to refine their writing?
Yes. So the PLOS, is it the PLOS family of journals does like the 10 simple rules stuff, and some of those are quite good. Excuse me. Brett mentioned Conrad Cording have a paper from 2017 in PLOS Computational Biology. It's like 10 simple rules for structuring papers, I want to say, for how to write scientific research papers. And there's quite a lot of those sort of little pieces. In my lab, I share, there's a couple of these sort of tips. I'm trying to remember. Oh gosh, what is it? There's like a nice paper that's also like, there's an editorial in Nature Methods, Should Scientists Tell Stories? I don't remember what year it is. I would say in eLife, if you look up Eve Marder, who is one of my science heroes, she has quite a few fantastic sort of like perspective pieces on sort of her thoughts on science. Another one that I just pulled up is, let's see, there's the classic, it's a Journal of Cell Science, 2008 by Schwartz. It's the importance of stupidity in scientific research, sort of embracing the fact that we don't know, and that's okay. That's the whole point of the science that we're doing. And I'd have to find other sources. There's like several books and things over the years that I've read. Naomi, I don't know if it's like appropriate to do, but maybe if you email me a follow-up question, I'll put together a list of resources, and I don't know if you can like send it to the attendees or something like that. I'd be happy to put that together because there's so many really good ones that I've read over the years.
Yeah, definitely. So I'm gonna write a blog post on the workshop, and also I'll send a blast email with the recording, and I can include those as well.
Okay, great. Vanya asks, anyone ask you about your opinion on The Last of Us zombies? What's really funny is I played The Last of Us when before the zombie book came out. I mean, well before, right? We even talk about cordyceps in our book as like a real thing that does seem to influence the behavior of certain kinds of animals, right? And so I think we even talk about Last of Us explicitly in the book, but it is a masterpiece of storytelling in the video game form, and also of the TV show is also fantastic. Opinion on the zombies. I mean, the TV show didn't have enough zombies, but it was still really good. And opinion on like their behavior or something like that. I mean, that's not going to happen. Right. I always have to like reassure people. We had a bad luck of timing when he did the zombie stuff, because we wrote a piece about the zombie brain, and the Centers for Disease Control in, I want to say 2011 or so, also came out with a handbook of like the science of surviving the zombie apocalypse. And they were doing this as like, sort of joke thing to people interested in emergency disaster preparedness. But here you've got two neuroscientists who write a book about zombies and zombie brains. And you have The Last of Us TV show, not The Last of Us, sorry, The Walking Dead TV show. And then the CDC releases a guide on surviving the zombie apocalypse. Oh, the number of kinds of emails that we got from people accusing us of like they knew for sure the zombie apocalypse was happening, and that we as part of this sort of like global elite were like getting people used to this idea, and they wanted to know the truth and stuff like that. So do I worry about always being resident zombie expert historian because of my book? No, we knew what we were getting into. It's fun. I enjoy zombie. We wrote it because I love zombie movies. But there are some of the bad sides. All right. I'm a communicator in a science organization. I've had some challenging conversations about dumbing down research when I'm working to make it accessible to a wider audience. Any tips for these conversations? My closest experience has been with the National Academy of Sciences, runs the Science and Entertainment Exchange. And I'll have conversations every now and then with people working on TV shows or movies. Yeah, you kind of do have to, I don't know, like dumbing it down is maybe more negative. You can try and work to simplify it, right? And sort of distill out the bare essence of whatever it is that you're trying to communicate, without ruining the scientific accuracy, right? You're like, okay, so in filmmaking terms or in screenwriting terms, right? Everybody gets one buy, which is sort of the one totally ridiculous, over the top thing that everybody agrees is nonsense and not real. And that's like the one nonsense thing that you're allowed to have, right? So you can have a movie about zombies where like, okay, we're gonna all accept suspend disbelief on the fact that zombies are real, but we're also not going to have then oh, and by the way, in addition to zombies, time travel is real, right? Like that's a second really big non-sciencey thing that's like too much for audiences to bear. And so like I try and make sure that when we're having these conversations about things that like the parts that are dumbed down are the parts that are within the scope of the suspension of disbelief by that the movie or film or piece has. But then they have to get the other science stuff right. I don't know if that helps or if that makes sense. You can maybe do a follow-up on that. And then somebody else said, when writing a layman's version of our work for public consumption, say for media purposes, how do you draw the line between the factual science you've done and over essentially sensationalism, which journalists notoriously do? I'd be very upfront with the journalists right away whenever I'm doing this, which is maybe why I'm not interviewed as often in journalists pieces, that I'm not going to do that. I think over sensationalism does a serious disservice to the public intellect and also then to the public trust. But the problem is that we can't get into the nitty-gritty details often because it requires a huge amount of knowledge in order to understand the nuance, right? And so you can't expect everybody to have like a undergraduate degree level of understanding of the nuances of neuroscientific research just in order to understand this nuance that you are trying to then portray. And so, you know, I try and be very upfront and honest and say, look, I will not sensationalize this. This is very promising for X, Y, and Z reasons, but it's also maybe not the panacea or cure-all or like, you know, this most mind-bending thing I have seen for also reasons X, Y, and Z. And it's coming up with those in as simple language as possible that is tricky. It is work, right? And so if I agree to do some kind of interview with a journalist, especially, I try and put in a little bit of work ahead of time to make sure that I've got my message clear in a way that is accessible. Do I know of any resources for science communication for other? Excuse me. For science communication for other scientists, for example, tweet summaries for new papers? If not, do you have ideas how I can make a central hub for these types of resources? I selfishly just want something more productive to do instead of doom scrolling social media in the morning, like a visual TLDR TikTok video of new papers. That's a great idea. Yeah, I don't actually know of something like that. Maybe that's your niche, Amber. Maybe that's something you could start creating. It would certainly, building something would certainly maybe help stave off some of the doom scrolling. Yeah. You know what? I don't know if I have it, but I'm gonna go ahead and I don't know of a way to message. I was gonna give my email address out to the people in here. And I don't know how to leave it because it's just host and panelists. Okay, my email address is just B as in Brad, my first name, Wojtek, V as in Victor, O Y Yankee, TEK. So BVOYTEK at UCSD.edu. And Amber, feel free to email me if I can think of something. I'll send it to you, and if not, you know, I'd love to hear what you're thinking. Sorry, I don't have more of a clear answer. Lou says, thanks, it's helpful. I see it as you do. My colleagues are the ones that sometimes say they don't want me to dumb it down. I'm trying to demonstrate the value of accessible information to them while maintaining the integrity of the science. That's great. More power to you. I wish that was the perspective that everybody was taking. All right. Well, like I said, feel free to email me if you have follow-up questions, anybody. And otherwise, I guess we can enjoy the rest of our afternoons.
Thank you so much. This talk was fantastic. And thank you everyone for coming. And I'll send out the recording and some follow-up resources soon.
Thank you so much, Naomi. Thank you everybody for coming. I appreciate it. Bye.
Bye.